Hello everyone, welcome to this session wherein we will be solving a problem related to wedge friction. And this is a statement. What it says is there are two blocks A and B weighing 15 kg and 3 kilonewton respectively, which are held in position against an inclined plane. So this is a block A which weighs 15 kilonewton. So weight of block A is 15 kilonewton and weight of block B is 3 kilonewton. So weight of block B is 3 kilonewton. They are held in positions on an inclined plane by applying a horizontal force P. So this is what is the horizontal force P that has been applied on the lower block B, so that block A is not allowed to move in the downward direction. So we need to find out that particular horizontal force P and find the least value of P and which will impede the motion of the block. So what will happen here is, if we apply a force P, this particular block P will move inward and the resistance force will be towards the left hand side. As the resistance force will be towards the left hand side, as this particular block moves inward, the block A will move in the upward direction and the frictional force will be in the downward direction. So frictional force will be always opposite to the movement of the body. Frictional force will be always opposite to the movement of the body. So a few things that we need to remember here is, first we need to draw free body diagram. Next we need to consider self-weight always to be in the vertically downward direction. Then normal reaction will be always perpendicular to the plane of contact. So this point is very important to be considered whenever we draw the free body diagram, to ensure that the normal reaction will be always opposite to the normal reaction will be always perpendicular to the plane of contact. Then frictional force will be always opposite to the movement of the body. Whichever direction the body tends to move, opposite to that particular direction, frictional force will be applied. Then the last important thing is the combination of both, that is the normal reaction and frictional force will be the resultant reaction force component, and this resultant reaction force component will always make an inclination of phi with respect to normal reaction. So we need to look at what particular position normal reaction force component is, and in between the both frictional force and normal reaction, always the resultant reaction force component will be subtending an inclination of phi with respect to the normal reaction. To begin with the solution, first step is to draw the free body diagram. To draw the free body diagram, we need to isolate both the body A and B. When we isolate both the body A and B, A face and B faces have been separated. So when we separate both the faces here, the inclination made for block B is 10 degrees here, and the same 10 degrees will be transferred at this particular junction. So if we draw this particular vertical face, because it's a vertical face, and then continue in this particular fashion. Now here normal reaction will be perpendicular to the plane of contact. Perpendicular to the plane of contact means it will make a 90 degrees to the plane of contact here. So when it makes 90 degrees here, this reaction shall be shown in the upward direction, and here on this face it will be shown in the downward direction. Reason is block A of 15 kilonewton will have the downward direction because it's a self-weight. Because of the gravitational attraction, the self-weight will be always in the vertically downward direction. Self-weight will be always vertically downward direction. Then this self-weight of this particular block is 3 kilonewton, which has been given. Self-weight of this particular block is 3 kilonewton, so it will also be acting in the downward direction. Now coming on to the normal reaction will make an inclination of 90 degrees to the plane of contact here. If this makes a 90 degrees to the plane of contact at this junction, and if the inclination here has been given as 10 degrees, the same inclination transferred here shall be 10 degrees. If this is 10 degrees and 90 degrees, the left out angle here shall be 80 degrees with reference to the horizontal. Same rule is applicable here. Inclination here is 10 degrees. So inclination shall be transferred here as an alternate angle as 10 degrees. Then again further alternate angle here shall be 10 degrees, and this angle shall be with respect to the x-axis shall be 90 degrees. We need to find out the inclination with respect to y-axis here. With respect to y-axis, this is x-axis is 80 degrees. With respect to y-axis, it shall be 10 degrees. Likewise, if I extend this particular x-axis line here and y-axis line, if this is 80 degrees and this inclination shall be 10 degrees at this particular phase. So these are nothing but the inclination of the normal reaction force component at the inclined phases. Likewise, normal reaction force component at the ground level here. Normal reaction, as the surface is horizontal, normal reaction will be in the vertical direction. Then coming on to this particular phase, at this location, if I extend this particular x-axis and the inclination been mentioned here as 75 degrees, and normal reaction will be again perpendicular to the plane of contact here, that is 90 degrees, and this inclination is 75, then the left out angle shall be 15 degrees here with reference to horizontal. If we extend the x-axis line here with reference to x-axis or with reference to the horizontal axis, it shall be normal reaction shall make an inclination of 15 degrees. So if we show the normal reaction at this phase, it shall make an inclination of 15 degrees at respect to the horizontal. So we shall name all these particular forces now. This force I shall name it as N1. Similarly, this to be N2, and this force shall be called as N3. Then horizontal force P is applied towards the right hand side. So which indicates if P is applied towards the right hand side, frictional force will be opposite to the movement of the body. If P is applied towards the right hand side, direction of impending motion is towards the right hand side. So resultant, that is, frictional force will be opposite to the movement of the body. So the frictional force will be towards the left hand side. Likewise, if this is left hand side, frictional force also shall be shown here in the upward direction, because both the surfaces are in contact with each other. So as per the rule, as it is in the upward direction, here to nullify, the frictional force shall be in the downward direction. So these are nothing but the direction of the frictional forces. Now here, this frictional force shall be called as F of F1, and this frictional force shall be called as F of F2, and this will be F of F2. Upward plus of F of F2 minus of F of F2, both the forces will be 0. Minus of N2 plus of N2, net vertical forces shall also be 0. If I separate this particular phase, which is nothing but the inclined phase, it will have a normal reaction force component and the frictional force component. This normal reaction force component, which will make an inclination of 10 degrees. Likewise, if I separate this particular phase and then draw, frictional force will be upward here, and normal reaction shall be shown here, which will make an inclination of 10 degrees with respect to the vertical axis. Now this is what is the direction of the frictional force. Now coming on to the frictional force direction at this particular phase. As this particular block moves inward, then what will be the status of block A? As B block moves inward, block A will move in the upward direction. So as a resultant, frictional force shall be in the downward direction, and this frictional force shall be called as F of F3, and this F of F3 will be in the downward direction because block A will move in the upward direction. So that is what is the direction of the frictional force, which will be always opposite to the movement of the body. Now next task is to combine normal reaction and then the frictional force. To combine normal reaction and frictional force, the combination of both the forces is called as the resultant reaction R, and this resultant reaction R will be in between the frictional force and the normal reaction. So as the frictional force here is downward, so normal reaction will be always in between the frictional force, which is F of F3, and the normal reaction. So here the normal reaction is upward, frictional force is towards the left hand side. Resultant reaction will come here as R1, and this R1 will make an inclination of 5 with respect to the normal reaction. Likewise here, frictional force is upward, normal reaction is inward, and resultant reaction force will be placed here, which will be called as R2, and this R2 will make an inclination of 12 degrees because that is angle of friction is been mentioned as 12 degrees. So that's why this is 12 degrees, this inclination is also 12 degrees. If I separate the force diagram chart for this particular block, force diagram chart will be shown like this. P to be acting towards the left hand side, and the quadrant system here will be first quadrant, second quadrant, third quadrant, and fourth quadrant. So this force will be called as R1, and inclination here shall be called as 12 degrees. Then moving on to this force here, which is nothing but R2. This R2, this is y-axis, and inclination here is 10 degrees. Here it is 12 degrees. Total angle with respect to y-axis, it shall be 10 plus 12, which will be 22 degrees. Likewise, moving on to this face now. frictional force is downward, normal reaction is upward, so combination of both will be nothing but the resultant reaction R2. And this resultant reaction R2 will make an inclination of 12 degrees with respect to the normal reaction, that is this normal reaction. Total inclination with respect to y-axis will be 10 plus 12, which will come out to 22 degrees. So if I draw the force diagram here, the force has been placed in this first quadrant. So certainly we can place the again force in the third quadrant. Here it is in third quadrant. If we extend the line, first quadrant, second quadrant and third quadrant. So you will be extending the force in the third quadrant, calling it as R3. And this R3 with respect to y-axis it is 22 degrees. Similarly here with respect to y-axis it shall be 22 degrees. If you make it a particular inclination here, the forces will be shown like this. This force is inward, this force is inward, this is 22 degrees. This inclination shall also be 22 degrees. Now self-weight is in the downward direction, which is 15 kilonewton load. Then at this particular phase, what will happen is frictional force and normal reaction. Both the combination of the force will be nothing but the resultant reaction R3. Now R3 will make an inclination of 5 with respect to the normal reaction. So normal reaction is here. So which will make an inclination of 5, which is 12 degrees. So with respect to horizontal axis, it will be how much? Total inclination will be 15 degrees. Why 15 degrees? If it is 15 degrees here, this is inclination is also 15 degrees. So that's why here it has been shown as 15 degrees. Resultant reaction will make an inclination of 12 degrees here. With respect to x-axis, it shall be making an inclination of 3 degrees. So which will be placed in which quadrant? First quadrant, second quadrant, third quadrant and fourth quadrant. So resultant reaction will make an inclination of, R3 will make an inclination of 3 degrees with respect to the x-axis. So these are the force diagram related to the second block, that is nothing but block A. That is R3 will make an inclination of 3 degrees, R2 will make an inclination of 22 degrees, 15 kilonewton force is shown in the downward direction. Likewise, R2 will make an inclination of 22 degrees in third quadrant. It will be transferred in first quadrant as 22 degrees. R1 will make an inclination of 12 degrees in the fourth quadrant. P force is acting towards the right hand side. Apart from that, 3 kilonewton force also needs to be shown in the downward direction. So these are all the forces pertaining to block A and pertaining to block B. Now we need to solve these particular blocks for, this is for block A and this is for block B. If we redraw this particular diagram for the solution purpose, for block A, the diagram was shown like this now. 15 kilonewton load downward. Then it has been divided in terms of the quadrant system. This resultant reaction force was named as R2. Resultant force was named as R3 here. This R3 would make an inclination of 3 degrees, whereas here it would make an inclination of 22 degrees with respect to y-axis. Here 22 degrees with respect to y-axis, 3 degrees with respect to x-axis. So same inclination have been represented here. Now to solve for this, since it is a 3 forces and all 3 forces are concurrent forces, and we will be applying Lamy's theorem. To apply Lamy's theorem, there are 3 forces here, 15 kilonewton, R2 and R3. So if I happen to consider 15 kilonewton load, it shall be sign of the inclination between the other 2 forces. If I consider 15 kilonewton load, other 2 forces are R2 and R3. So inclination between R2 and R3 needs to be calculated. That particular inclination between R2 and R3 will be 22 degrees. If this is 3 degrees, this inclination shall be 87 degrees, because 90 minus 3 shall come out to 87 degrees. So inclination between R2 and R3 will be 87 plus 22. So 87 plus 22 is nothing but the inclination between R2 and R3, which shall come out to 109. So inclination between R2 and R3 is 109. Likewise, we need to calculate the inclination of R2 now. When I consider R2, inclination between 15 and R3. R3 is here, 15 is here. So total inclination here shall be 90 plus of 3, which shall be 93 degrees. So if I write down R2 here, it will be sine of 93 degrees, which is nothing but the inclination between 15 and R3. It's the inclination between 15 and R3. Likewise, the last force, which I write it as R3, if I consider R3, I need to consider the inclination between 15 and R2. If this is 22 degrees, what shall be this inclination? 90 minus 22 degrees, which shall come out to 68 degrees. So among 68, this angle will be added now, which will be total inclination here shall be 90 plus of 68, which shall come out to 158 degrees. So here it shall be 90 plus 68, 90 plus 68 shall come out to 158 degrees. So this inclination shall be 158 degrees. So we shall write it here as sine of 158 degrees. This is the inclination between 15 and R2. When I consider R3, it will be 15 and R2. When I consider R2, it will be 15 and R3. When I consider 15, it will be R2 and R3. To reframing this equation, I shall find out the value of R2 and R3. To find out the value of R2 and R3, I shall cross multiply here. 15 divided by sine of 109 multiply by sine of 93, which shall come out to 15.84. R2 value will come out to 15.84 kilonewton, whereas R3 value shall come out to 15 divided by sine of 109 multiply by sine of 158, and whose value shall come out to 5.94. Here it shall be 5.94 kilonewton. That is, the value of R3 here is 5.94, whereas the value of R2 here is 15.84. Same 15.84 we are going to make use it for the block B. So if we consider for block B, 3 kilonewton force is acting downward. On the other hand, R2, which has been shown in the third quadrant, shall be shown in the first quadrant, making an inclination of 22 degrees with respect to y-axis. So R2 shall be shown in the first quadrant, making an inclination of 22 degrees. 3 kilonewton is being shown downward. P will be shown towards the right hand side. Then in this particular fourth quadrant, you also have a force called as R1, which will make an inclination of 12 degrees. Shall make an inclination of 12 degrees. Check out. For R1 will make an inclination of 12 degrees. So these are the forces pertaining to block B. Now here we cannot apply Lamy's theorem because there are four forces. P, 3 kilonewton, R2 and R1. So we cannot apply Lamy's theorem. Lamy's theorem is applicable only when you have 3 concurrent force system. When you have 4 concurrent force system, we need to use equations of equilibrium. When I use equation of equilibrium, this force is inward. I need to resolve this particular force component. Resolution of the force component, as it is an inward force component, both the forces will be inward, and this force component will be R2 sine of 22, and here this will be R2 cos of 22 degrees. Reason, to this 22, this side will be opposite, sine of 22, this side will be adjacent, cos of 22. Likewise, R1 when I resolve, it will have a force component placed in the fourth quadrant. As it is again an inward force component, both the forces will be inward, and vertical force component will be R1 sine of, if I resolve this will be shown in the downward direction because 12 degrees has been shown with respect to y-axis. So this is 12 degrees. So R1 sine of 12 degrees. And here vertical component will be R1 cos of 12 degrees. So if you consider this as an independent triangle, this is 12 degrees. So this shall be sine of 12. This shall be cos of 12. So this will be R1 sine 12 and this will be R1 cos of 12 degrees. So these are the forces that is in pertaining to R1 and R2. 3 kilonewton and P shall not be resolved because these are already the forces parallel to X and Y. This 3 is parallel to Y axis, P is parallel to X axis. So I shall apply summation Fy is equal to 0. When I apply summation Fy is equal to 0, here R2 cos 22 is downward. So minus R2 cos of 22 degrees because it is downward force. Minus of 3 kilonewton. P shall not be considered because it's a force parallel to X direction. R1 shall be considering the Y component force and its Y component is upward. So plus of R1 cos of 12 degrees, that is equal to 0. So if we solve this, R2 value is already known to us, which is nothing but 15.84. So we need to substitute this particular value. Minus 15.84 cos of 22 minus of 3 plus of R1 cos of 12 degrees, that is equal to 0. So R1 cos 12 degrees is equal to 3 plus 15.84 cos of 22 degrees. That is when you reframe the equation. So R1 will be equals to 3 plus 15.84 cos of 22 degrees, which shall come out to 17.6869 divided by cos of 12 degrees. So R1 value will be divided by cos of 12 degrees, which will be 18.08 degrees, 18.08 kilonewton. This is the value of R1 now. Now we need to find out the value of P. So I shall consider summation Fx is equal to 0. When I consider summation Fx is equal to 0, P is on right hand side, so plus of P. And here 3 shall not be considered because it's a force parallel to Y. R2 will have a force component along x direction, which is left hand side, and its component will be minus of R2 cos of sine of 22 degrees, because R2 sine 22 is left hand side, so minus R2 sine of 22 degrees. Likewise, R1 sine 12 degrees is towards the left hand side, minus R1 sine 12 degrees left hand side, so minus, that is equal to 0. So substitute the value of R2. R2 value is calculated as 15.84. So when you take it on right hand side, which will be positive, 15.84 sine of 22. R1 value is 18.08. When you take it on right hand side, positive, 18.08 sine of 12 degrees. So P value shall come out to 15.84 sine of 22 plus 18.08 sine of 12 degrees, and whose value shall come out to 9.693 kilonewton. So this is the value of P that will be required to applied on the particular block B, so that block A does not slide downward and both the system is kept under equilibrium position. So this is how we are supposed to solve a particular block. So most important thing to check out is always normal reaction will make an inclination of 90 degrees to the plane of contact, and frictional force will be always opposite to the moment of the body, and in between both it will be a resultant reaction R, which will make an inclination phi with respect to the normal reaction. Resultant reaction R will make an inclination of phi with respect to normal reaction. Likewise here, resultant reaction R will make an inclination of phi with respect to normal reaction. This care we need to take such a way that resultant reaction R will always make an inclination of normal reaction and never any inclination with respect to the frictional force. If we follow these particular conditions, we are able to find out the value of P, which was 9.69 kilonewton. So this is what is the value of P that has been calculated. So this is how the wedge frictions have been solved. Thank you. Have a nice day.